6-3, Solving Systems Using Elimination. So, for the past 2 lessons in Chapter 6, we have learned how to solve a system of linear equations. We know 2 ways so far. We've talked about in 6-1, we can use graphing to find where the point of the systems intersect. And in 6-2, we learned a method called substitution. This lesson in 6-3 is elimination. Let me show you how it works. Alright, now, when we eliminate an equation, we can do it by either adding or subtracting. Here's how you know which one to do. Okay, looking at our 2 equations here in our system, 2x plus 5y equals 17, and 6x minus 5y equals negative 9. Now, if you look closely, the coefficients of the y values are opposite in each equation. The first equation has a positive 5y, and the second equation has a negative 5y. So if you ever see a coefficient in front of a variable and they're opposite, we can eliminate, hence the elimination, we can eliminate that variable from the system. Here's what I mean. I'm going to rewrite these equations. Right here, my positive 5y and my negative 5y, if I were to add these 2 equations together, 5 plus a negative 5 would cancel out. I now have 0y. I have eliminated the y's from these equations. Now, 17 plus 17, oh, I wrote the equation wrong. 17 plus a negative 9 gives you 8. And 2x plus 6x is 8x. So my equation is 8x equals 8. Solve for x by dividing 8 on both sides. X equals 1. That is the x coordinate of my solution. I'm going to plug x equals 1 into either of the 2 original equations. I'll just use the first. 2 times 1 plus 5y equals 17. 2 plus 5y. Subtract the 2, y equals 3. The solution to this system of equations is positive 1, positive 3. Now, we can also solve the system by eliminating, and we have to subtract to do so. Alright, this one has a word problem. The theater club sells a total of 101 tickets to their first play. A student ticket costs $1, an adult ticket costs $2.50. Total ticket sales are $164. How many student tickets were sold? That's what we're trying to answer. Alright, so we need to set up our equations. First, we're going to relate the total number of tickets. So student tickets plus adult tickets that we sold this first play night is 101. And now we're going to relate the cost of those. It says student tickets are $1, 1 times x, and adult tickets are $2.50 times y, and we made $164. So there are our 2 equations. I'm going to line, using a different color, I'm just going to line up our equations so we can look at them. And x plus 250y equals 164. Alright, I see this y, coefficient of y is 1, this coefficient is 250. They're not the same or opposite. This coefficient of this first equation is 1, so is it in our second equation. Well, in the last example, we could add the equations together, and since they had opposite signs, they would eliminate. This isn't the case. If I were to add these equations together, I would get 2x, and it wouldn't be eliminated from the equations. So we can subtract the equations when your coefficient is the exact same. So I'm going to now subtract these 2 equations. Now my x minus x cancels out. Now I have 1y minus 250y. I get negative 1.5y. And 101 minus 164, I get a negative 63. Now I can divide by negative 1.5, divide by negative 1.5, y equals 42. So that is how many adult tickets we sold, because that's our y value in our equation. We want to know how many student tickets. So we need to put this y value back into one of our original equations. I'll use the first one. X plus 42 equals 101. X equals 59. 59 student tickets were sold, 42 adult tickets were sold. That is elimination by subtracting equations. Now, problem 3, solving a system by multiplying one equation. If we look at the two equations in this system, there are no coefficients of either of our variables that are the same or opposite. I have negative 2x and 7x, 15y, and negative 5y. What you can do to make the elimination process work is you can multiply one equation by a number so that it matches the other equation. Meaning, this second equation, if I multiply all three parts of the equation by 3, my coefficients will line up. Let me show you what I mean. I'm going to rewrite my equations. Negative 2x plus 15y equals negative 32. And my second, 7x minus 5y equals 17. I'm going to multiply this equation by 3. And when I do that, I have to multiply it to all three parts of the equation. So my new equation, 7x times 3 is 21x. Negative 5y times 3 is negative 15y. And 17 times 3 is 51. Now, I'm going to rewrite this top equation that stayed the same. I'll write it above here. Negative 2x plus 15y equals negative 32. I like to line my things up. All right, now, because I multiplied by one equation, I made the coefficients of my y's opposite. When they're opposite, I can add the two equations together. Negative 2x plus 21x is 19x. 15y plus a negative 15y is 0. The y's have been eliminated. Negative 32 plus 51 is 19. Divide by 19 on both sides. X equals 1. Now I'm going to put x equals 1 back into my original equation. I will choose, doesn't really matter, I'll choose this first one up here. Negative 2 times my x value of 1 plus 15y equals negative 32. Simplify. Add my 2. Y equals 2. The solution to this system is 1, 2. Oh, sorry. As I check my work. This should be a negative 30 and a negative 2. 1, negative 2. Sorry about that. Now, we can also solve a system by multiplying both equations. If you look at two equations in your system, now don't forget, you can always use graphing and the substitution method to find your solution. However, if you want to eliminate and none of the coefficients of the two equations in your system are alike or opposite, you can multiply both equations by a number so that you get like coefficients. Now, you don't have to multiply the same number to both equations, just as long as whatever you multiply to the first one, you multiply to all parts, and whatever you multiply to the second equation, you multiply to all parts. So, what is something we could multiply the first equation by or the second equation by to get a coefficient of either x or y to be the same? I'm going to multiply the first equation by 3 and the second equation by 2. Let's see what that does. All right, 3x times 3, 9x. 2y times 3, 6y. 1 times 3 is 3. Now on the bottom, I'm multiplying this equation by 2. 4x times 2 is 8x. 3y times 2 is 6y. Negative 2 times 2 is negative 4. Notice that doing this, multiplying both equations by a number, my coefficients of my y variable are the same. When they're the same, I can subtract the equations. 9 minus 8 is just x. 6 minus 6 eliminates y. 3 minus a negative 4 is a positive 7. X equals 7. Put x equals 7 into an original equation. 3 times 7 plus 2y equals 1. 3 times 7 is 21. Subtract the 21. Divide by 2. Y equals negative 10. My solution to this system is 7, negative 10. I had to multiply both equations to get this solution. Finally, just like our last example in lesson 6-2 with substitution, we could find out if a system had infinitely many solutions or no solution. Basically how we did this is using substitution. If our answers at the end equaled each other, we said they were an infinite number of solutions. If at the end we got two numbers that did not equal each other once the variables were eliminated from the equations, we said there was no solution to that system. We can do the same thing with the elimination. So here are my two equations. I need to figure out what I need to do to eliminate one of the variables. If I look at my y's here or my x's, I could multiply one of these equations by one number to very easily make them the same coefficient. I'm going to multiply this bottom equation by 2, making it 2x, which will match the first equation. So first equation is 2x plus 6y equals 18. I'm leaving that one. This equation I'm going to multiply by 2 to all parts. 2 times x is 2x. 2 times 3y is 6y. 2 times 9 is 18. All right, I have the same coefficient of my x's, so I'm going to subtract these two equations. 2x minus 2x is 0. 6y minus 6y is 0. 18 minus 18 is 0. My final answer is 0 equals 0. Well, those are the same numbers that equal to each other. This system has an infinite number of solutions. This is kind of a really nice reference. It's in your textbook as well on page 377. Oops. Let me write that for you. Page 377. Basically, this flowchart will help you decide which steps to take when solving equations or a system of equations using elimination. Ask yourself, can I eliminate a variable by adding or subtracting? If yes, then do so. If you can't, multiply one of the equations by a number and then add or subtract. If you can do that, do it. If you can't, you might have to multiply both equations by a number. Complete the lesson check and bring your questions to class.